Hello, everyone. My name is John Barnshaw. I'm the Vice President for Research and Data Science at Astra, and welcome to another Astra Academy. Today, it is my privilege to welcome Elizabeth Zachry Rutschow. Dr. Rutschow is a Senior Research Associate at MDRC, and she's going to be sharing some very interesting information about aligning math pathways to improve outcomes. A little bit of an overview and an introduction. If this is your first Astra Academy, welcome. I'm going to provide a little bit of an overview and an introduction. I'm going to then turn it over to Elizabeth, who will provide a detailed exploration of the Dana Center Math Pathways project research that she has conducted. And then at the end, we will take your questions and comments. A couple points of note. One, of this recording as well as the presentation will be available to all registrants and attendees of this webinar following the webinar. And two, during the questions and comments period, if you look at the bottom of your tab, you will see a chat button. If you wish to chat, you can reach out to me directly, John Barnshaw. I'm in the chat under a panelist, and you can send me your questions that way, or you can type them into the chat box, and a panelist will try to get to as many questions as possible during the question and answer period. So a little bit about Astra. We are a course scheduling and enrollment management organization, and we partner with over 500 institutions of higher education annually to improve course scheduling accessibility and efficiency for students. We offer unique to basically help improve students to retain them and graduate them faster. And Astra Academy is a webinar series that we provide to diverse stakeholders in higher education across the landscape with a focus on retention, time to completion, and or graduation. I'm very excited today to have Elizabeth talk about her research because she touches upon both of those things and so much more. At Astra, we work with many of our institutions to help align the course schedule to help retain and graduate students faster by using the course schedule. And Elizabeth's research actually partners with institutions to help with math pathways. So as many students and institutions consider the possibility of going from a remedial model to a co-requisite model, Elizabeth has some research that can hopefully inform that decision. For those of you that are already in that process and are interested in learning more about rigorous research around this, I think you will find that Elizabeth will provide you a very thoughtful and well-designed presentation over the next time. So without further ado, I'd like to turn it over to Elizabeth. Liz?
Hi. I am Elizabeth Zachry Rutschow, and thank you, John, for that introduction. I'm going to talk to you a little bit today about a rigorous research study that we conducted of one math pathways model, the Dana Center Mathematics Pathways. It will include a number of different types of research, including looking at how the program was implemented at the colleges, how the costs of the program, and then their effects on student outcomes. This research was funded by the U.S. Department of Education Institution of Education Sciences by a grant that was given to the Center for the Analysis of Postsecondary Readiness. The Center for the Analysis of Postsecondary Readiness, or CAPR for short, is a partnership between CCRC and MDRC. We are, the center primarily had three central studies as part of its work. One was a descriptive study looking at the prevalence and scale of different developmental education reforms across the country using a national survey and some qualitative interviews. An evaluation of new assessment practices that included multiple measures in addition to the use of standardized tests to place students in developmental and college level courses, and then the evaluation of the Dana Center Mathematics Pathways. In addition, we had a number of supplemental studies through partnerships with a number of academics across the country. So today I'm going to talk to you about this third study here, which is the evaluation of the Dana Center Mathematics Pathways, or DCMP for short. So to begin, let's talk a little bit about why we might want to think about doing accelerated math pathways. So there's obviously been a lots of reform of developmental education lately, particularly trying to accelerate students' progress through developmental courses or placing them directly into college level courses with supports. However, though these reforms attempt to look at some of the challenges around having long course sequences with multiple exit points, not all of the reforms have really looked at challenges with the content of the classes that students are being required to take. So the Dana Center Mathematics Pathways really tries to deal with both of these issues. When you look more closely at the kinds of math that students need when going into their careers, really only a small fraction of careers and majors really require the use of calculus. So about 80% of majors in community colleges and about 72% of majors in programs of study do not require calculus in four-year colleges. Another challenge with math courses has also focused on the challenges with the pedagogy or instruction used in those courses. So as you can see here in this cartoon, traditional math has tended to focus primarily on teacher-directed learning, with teachers at the board lecturing students, often through the use of formulas and equations. Much of the discussion of math and teaching of math has focused on the understanding of formulas and rote memorization of those formulas, with students reproducing those and showing that they can use these formulas on exams. And then often, as you can see in this cartoon, there tends to be very few real-world applications. Instead, students are often being asked to just solve for X. In contrast, I'm going to talk to you a little bit about the Dana Center Mathematics Pathways. The DCMP is both a larger, broad model. So one, in particular, the Dana Center Math Pathways is really structured around 4 broad principles. The idea is that math pathways should be structured around students' career interests and programs of study in math that aligns directly with the kinds of careers that they will be in later in their lives. The math that they will use most often is the math that they should be learning in college, and that students should get to that college level math as quickly as possible, ideally within the first year of college. In addition, 2 of their principles focus on the quality of supports that students received, encouraging institutions to integrate supports holistically around the student to be able to support their learning and progress, and also that the curriculum and instruction that they receive is based around evidence-based reforms that support students' understanding and learning. So the Dana Center, the Charles A. Dana Center at the University of Texas at Austin was the creator of the DCMP. And right now the Dana Center works broadly across the nation, as well as states, institutions, and classrooms to think about how to implement math pathways writ large. A lot of their work has focused on changing national and state policies to be able to better provide multiple math pathways for students that do not necessarily require an algebra-focused or calculus-focused subject. In addition, they work a lot with states to be able to help integrate across post-secondary systems to be able to do this work. Today, I'm going to be talking to you more about the institution level work, the institution level work and the classroom work that the Dana Center is also doing. So when we think a little bit about the DCMP curricular model, we want to contrast it with the traditional model of developmental education. The model I have shown up here is the old standard model, I'd say maybe about 5 to 10 years ago. Students that were in need of 2 or more developmental courses traditionally had to start with a beginning algebra course for a full semester, and then after, if they were successful in that course, they would enroll in a second intermediate algebra course in the second semester, and then generally would go on to college algebra. Some students could go on to quantitative reasoning or statistics classes, but often students were required to take college algebra before taking those courses. The DCMP focuses on diversifying this math content into 3 different pathways, each of which start with an accelerated and revised developmental math course, called the Foundations of Mathematical Reasoning. This 1 semester course provides a broad overview of both algebra as well as more statistics and quantitative reasoning content, which is aimed at providing students with all the information they would need to be prepared for a college level course in their second semester, either statistical reasoning or quantitative reasoning. In addition, for students that were interested in STEM pathways, students could move on to a reasoning with functions pathway, which consisted of 2 courses that would prepare students for calculus. Today, I'm going to talk to you in our evaluation primarily about the first 2 pathways, so the statistical reasoning and quantitative reasoning courses. This is primarily because the reasoning with functions courses were not fully developed at the time that this evaluation started. So, in contrast to the traditional instructional models that I provided, that I discussed a little bit earlier, the Data Center Math Pathways looks at revising these in a number of different ways. First, it focuses on providing students with small group work where they're working together to problem solve with one another, with the instructor acting more as a facilitator rather than lecturing. In addition, instructors might provide many lectures or small lectures, but students would be asked to be the primary problem solvers, often going up to the board to present multiple types of solution methods to other students, or helping encourage and tutor other students in the class as they work through their own problems. In addition, many of the Data Center Mathematics Pathways problems are presented narratively, requiring reading, and students are often asked to write out in narrative form a justification for their answers, often in complete sentences. The problems generally build upon one another, where students are using an answer they achieved in an earlier part of the problem in a secondary and third step to the problem later on. In addition, the instructor is encouraged to encourage students to find their own answers. So rather than directly answering students' questions, instructors would try to encourage students' constructive perseverance, which would be to prod them along, perhaps answering a question with another question, or providing them with hints rather than direct answers to a problem. And then finally, the problems in the DCMP curricula are provided within context of real-life situations. So to give you an example of this, here I've provided you with a typical algebra problem that we saw in our observations of courses. As you can see, this problem is focused on solving for y, with students encountering a formula and then providing a numeric answer to that equation. In contrast, this is a typical DCMP developmental math problem. As you can see, the question is written out narratively, and it requires students to develop their own equation and to think about how the various numbers presented compare to one another. Here I've provided a bit of the answer for you, but generally students would be asked to write out in a complete sentence this type of answer with their own numeric solution. So now I'm going to talk to you a little bit about the evaluation of the DCMP curricular pathways. Overall, the research questions sought to focus on whether or not colleges, when they were implementing the DCMP pathways, and in particular at the institution level and at the classroom level, whether or not they were implementing the DCMP model and the principles as was hoped or as was expected. And then in addition to that, we looked at whether or not these courses had any effects on student outcomes, and then the overall cost to colleges to implement and maintain the DCMP in comparison to business as usual courses. So this study was designed as a randomized controlled trial study. It was conducted at 4 colleges in Texas and included 4 cohorts of students from fall 2015 through spring 2017, and included a total of 1,411 students. So in this study, we look at both the impacts and the types of data collected in order to look at the impact of the DCMP on student outcomes. Was primarily student-level transcript data, which was provided to us by each of the colleges. In addition, we received, looked into IPEDS data to be able to track students in case they had transferred to other colleges. The key outcomes that we talk about in this particular presentation are the completion of developmental math, the completion of college-level math courses, and students' overall academic progress. Right now, we have 3 to 4 semesters of data to follow up. We're hoping to be able to do additional analyses of the data if we get further funding. In addition, we looked at the implementation, both at the institution level of the courses and the curriculum and pedagogy in the classes. So in order to do this, we conducted site visits to colleges, where we conducted interviews with faculty, administrators, and staff. We observed 48 DCMP and non-DCMP classes, both at the developmental and the college level, and conducted focus group with students. In addition to this qualitative data, we did a survey of students in the sample. The survey was given to all students in the sample, both those students in the DCMP course pathways and those that were in the standard courses. And the survey focused on having students provide information about the way that their math classes were structured and taught, as well as their perspectives of their classes, their math skills, and their overall perspective of math itself. And finally, we conducted a cost study. We gathered cost data from each of the colleges as well as the Dana Center. We analyzed cost both at the startup level, which was a 2-year period for the colleges, as well as ongoing cost, which was a 1-year period after the startup was completed. And then these were costs were examined in comparison to the college's expenses around regular services and regular courses. In addition, we estimated the cost that colleges might have for receiving some of the supports that the Dana Center provided to the colleges that are in this study. So now I'm going to talk to you a little bit about our implementation findings and our findings from the cost study. So at the institution level, we found that the overall implementation of the pathways was relatively strong. In particular, we found that colleges worked hard to revise the types of math requirements that were a part of their majors. So for instance, one of the things, in order to successfully implement math pathways, you would need to revise the kinds of math courses that are required for a number of majors. For instance, things like psychology, nursing, or other humanities majors. We found that colleges generally did this, though the strength of these revisions, or at least the extent of these revisions, varied from colleges. We had some colleges that revised all their majors that were non-STEM majors to sort of have math pathways be the standard courses that the students would be taking, whereas other colleges only revised the courses for 30 or 40 majors. Colleges also were very strong in revising their advising practices in order to be able to identify the kinds of majors or career interests that students had to be able to place them into the appropriate pathway. In addition, all of the colleges scaled the DCMP courses beyond what they had originally started with, generally up to at least 3 sections per semester, with many having 5 or more. Some of the challenges, though there was quite a bit of alignment around with 4-year colleges, and this in particular was also a challenge for many 2-year colleges. As you might expect, many colleges, 2-year colleges were concerned about whether or not these differing math courses would actually transfer over to students if they were to enter into a 4-year college, and whether or not those math courses would apply towards their future majors at 4-year colleges, or whether or not they would be required to retake developmental or college level algebra courses. Overall, we worked with both the colleges at the 2-year level and the 4-year colleges at the 4-year level to negotiate agreements that allowed them to accept these majors as these math courses as part of this study. However, there were several 4-year colleges that still wanted to require math, certain types of math for students in majors. So for instance, some colleges wanted students to take a specific statistics class for sociology or psychology rather than allowing a more general statistics course to apply to that major. Others might want courses like, majors like nursing to still have algebra as its main math course. In addition, we found that generally the student supports were strong at each of the colleges. There were often computer labs, tutoring labs, math labs, and a number of supports to help students with their math. However, particularly at the beginning of the study, we found that some of the tutors in the math centers were not familiar with the DCMP curricula and methods, and sometimes struggled to provide supports for students as a result. Overall, we found that there was also relatively strong fidelity to the DCMP curricula as it was implemented in the classrooms. So as we went, we would go and observe a class, and then we would interview a faculty member as well as do a focus group with students that were participating in that particular class that we saw. And we generally tried to do a triangulation of that data to understand whether or not the class that we observed was typical of how the class was generally taught throughout the semester. So these ratings and this information were based around that information, thinking more about kind of the longer term instruction in the classrooms. So in the classrooms, we found a markedly different instructional environment than what we often found in traditional classes. We found that students were often coming into class, broken off into groups of 3 or 4, working together. There was often a lot of talking, and often if teachers provided any lecture, there was just a mini lecture around a particular skill, and then students were asked to work on problems on their own together in the classroom. In addition, we found that the problems that students were working on tended to be highly contextualized, and that students were required to read and write. And students also were required to use a technology program as part of their homework. We found in our focus groups that students often commented on how much better they understood how math would apply to their lives. And this quote that I've provided here is just one typical one of what we would often hear from DCMP students about how they could better compare different sales or sales tactics or marketing to decide whether or not the costs that were required were actually a savings or more expensive. Instructors also talked about the differences in how the courses were taught and how the problems were framed for students. The instructors often commented that it required a lot of prep time in the very beginning to kind of learn this different teaching method, though this preparation time often was reduced over time as instructors became more familiar with the material and the teaching method. So in thinking and looking at standard classes, we went to both beginning algebra and intermediate algebra classes, which were really the only developmental classes that were offered at these colleges for students in the taking developmental courses outside of the DCMP pathways. And we found that there was a very strong contrast between those classes and those with the DCMP courses. So the classes that we observed tended to be very lecture-based, with a teacher at the front of the class going over formulas, often on a whiteboard or on a projector, that with the instructor writing out the formula or equations and asking students to work on their own to be able to solve problems. Every once in a while, instructors would ask students to answer out loud what an answer might be, but generally the instructor provided the solution method for how to do that, and generally focused on one type of solution method rather than a number of different types of ways that a problem could be solved. We found that there was very little contextualization of these equations or formulas, and that students were generally, outside of note-taking, generally required to do very little reading or writing. The one main similarity that we found was in the use of technology in these courses, where students were asked to use calculators, and then often also were working through a computer-based program like My Math Lab to help support their learning. And as you can see here, developmental math instructors talked about how they taught their class, and talked about how they generally focused on a lecture-based instructional method, though, and acknowledging that they were fearful that it would take more prep time if they were to do more active learning methods. So I think one of the most exciting parts of these this study was really the student survey, and to be able to see students' perspectives through the kind of randomized method of whether or not their experiences in classes were different. As I mentioned, this survey was disseminated to all students in the sample, and we got about a 70% response rate, so relatively high response rates from the students. And as you look at these numbers, I also want you to consider that the students that were asked these questions were actually students that were taking a math course that semester. So the numbers that are, those that were not taking a math course were imputed as 0. So the numbers and percentages you're going to see here are actually smaller than what they likely would have been if it were students that were only in standard math classes and DCMP classes. So here you can see very strong differences in the types of instruction that students said that they received in their classes. This is very unusual to see in an instructional study from what we have conducted in the past. When we have looked at things like learning communities or student success courses, we often find that students really perceive very little difference in how their courses are taught or the supports that they learned about. Whereas here you can see in some cases 40, 50 percentage point differences in the ways that students learned math. In particular, there was many students in DCMP classes working with other students, many more students being asked to write out their reasoning, and many more students saying that they used problems with information from real life. And all of these answers were, differences were significant at the 0.01 level, which means that there was a less than 1% chance that these results were due to chance. In addition, students talked about their perspectives of their math class, and you'll see here that we also saw statistically significant differences in the kinds of math that students were learning, whether or not they found the math was interesting, whether or not it applied to their daily lives. They also found that the class tended to make them feel more confident in their ability, as well as increased their interest in math. However, I also want you to note that most of these percentages are still around half or fewer of the students that were answering these, meaning that there are large proportions of students that are not finding these attributes of their classes as a strong thing, or that an attribute of their interest in math. Finally, we look a little bit about whether or not students talked about whether or not their attitudes towards math had changed. And here we see a statistically significant difference in students' thoughts on whether or not the math that they learned would be used in their everyday lives, but we do not see statistically significant differences in students' confidence with math, their confidence in their ability to handle difficulties in math, and whether or not they saw math learning as enjoyable. In these cases, less than 50% of the students for each of these, less of the 50% of the students in the sample found that these characteristics of math applied to them. Overall, we found that in the startup period, the average startup cost per colleges was about $140,000. And that price, generally that price was primarily due to the kind of training of faculty and the setup of administrative costs of revising the majors and a kind of institutional pathways to be able to implement the courses. Once the courses and the pathways were up and running, the net costs were much lower, just over $19,000, or less than 1% of colleges' annual operating budgets overall. So now I'm going to talk to you a little bit about the impacts on students' achievement from the DCMP courses. So first, one of our primary outcomes of interest was to look at whether or not students were passing developmental math at higher rates. And you'll see here that after one semester, we see statistically significant differences in the number of students enrolling in math, in passing developmental math, and particularly in completing their sequence. We think this was primarily due to the fact that the Dana Center math pathways could be, students could complete their sequence in one semester, whereas many of the students in the sample were required to take 2 or more semesters of developmental math. We've also had questions before about whether or not this enrollment number, what that might mean. There's a chance that some of the registration practices may have affected these numbers, although we found that we did work closely with the staff at each of the colleges to register both students in the DCMP pathways and in the standard pathways into courses as soon as they had entered the study. However, it's possible it was harder for students to drop the courses in the DCMP pathways or enter the courses in the DCMP pathways, so that could be some of the differences in the registration rates. By semester 3 or 3 semesters after their entry into the study, we see that these statistically significant differences are still occurring, even after students in the standard group would have had a chance to catch up in their developmental courses. As you can see, each of these are still significant at the 0.01 level, with more students in the DCMP pathways passing courses, developmental courses, and completing their sequences. In addition, we see impacts on students' completion of a college-level math course in their second semester. So in their second semester, students, particularly in the program group and the students that were allowed the opportunity to take the DCMP courses, would have been eligible. Those that were successful in the foundations course, developmental course, would be eligible to take a college-level math course. As you can see here, many students, some students were able to successfully enroll in these courses and complete these courses in their second semester. And these numbers grew over the third semester after entry into the study. And each of these, again, is significant at the 0.01 level. So we also see impacts on students' college-level math credit accumulation. Here you can see that students are both attempting and earning math credits at higher levels among the program group than those in the standard courses. However, at this time, we don't yet see an impact on students' overall credit earning. However, one thing to consider with this is we also don't see students taking fewer other classes outside of math classes in this case, which is also a kind of good outcome. We might expect to see more impacts on credits earned in later semesters of the study if we were able to do more follow-up. And then after 3 semesters, as you might expect, we did not really see any impacts on some of these longer-term outcomes, like graduation or receipt of a degree. However, if we looked at the first 3 cohorts that entered the study, we do see some promising news where students are in the program group are receiving credentials, and these are credentials that are generally able to be completed in less than a 2-year time period among students that are in the program group. So in addition to looking at the overall sample, we looked at a couple of subgroups. These are considered exploratory analyses because these do not necessarily include the whole sample, or rather the sample is broken into subgroups. So you can interpret these with some caution, though the random assignment process still applies. It's just not necessarily randomly assigned per group that needs, for instance, 2 or more math courses versus those that need 1 or fewer dev math courses. And in general, what we see here is that the DCMP courses were particularly impactful for students that needed 2 or more developmental math courses, and less so or not impactful for students that needed 1 or fewer. This is likely, understandable given that students that needed 1 or even no developmental math courses had fewer math courses that they needed to complete in comparison to the students that were in the standard group, thus likely showing these differences in the impacts. However, we can see that this is particularly a useful model for those students that need multiple developmental math courses. In addition, we looked at the impact of the credits earned. Again, we see impacts for students with higher developmental math needs on both their college level math credits earned as well as their total credits earned. However, we do not see this in college level math classes for students that had 1 or fewer developmental math course needs. And in fact, we saw an impact on students that, or reduced impact for students that were in the program group for the total credits earned. And this was likely, again, due to the fact that these students were in the program group, were taking a developmental course in that first semester when they may not necessarily have needed to if they did not have any developmental needs. And a few of those students did make it into the sample. I didn't have a chance to provide you with all of that background information, but it is in our report, which I'll provide you a link to in just a minute. So additionally, we looked at impacts by enrollment status. And what we found here is that we found impacts on students' completion of their developmental math sequence and their completion of a college level math class for both full-time and part-time students, though the differences are starker among students that are going part-time. We saw no impacts on the number of college level math credits earned or total credits earned among full-time students, but we did continue to see an impact in the college level math credits earned among part-time students. So a few thoughts on the implications of these findings. First, I think foremost we can say that the DCMP is effective in helping students succeed in college math, though we need to have more time to actually see its effect on longer term outcomes. We can also say, from at least what we've seen, that traditional instructional models seem to continue to dominate the developmental algebra and college level algebra courses that we observed. However, we have seen from the observations and discussions with students and faculty that this kind of instruction can be changed with some effort. However, we should also note that math is still a significant barrier for many students' success. So though we've seen significant differences from the DCMP program, we see that only 1/4 of program students were completing a college level math class in 3 semesters, and less than 40% of students said that they felt confident in math or that math learning was enjoyable regardless of which group they were in. So what more can we do? Some suggestions might be to think about ways to improve students' interest and enjoyment of math overall. And I think the DCMP curricular models show that those kinds of student-centered models, contextualized instructional models, can help change students' perspectives. We also need to improve the research on teaching and learning and its connection to student outcomes. This study looked at grades and passing courses as kind of a broad measure of student learning outcomes, but we really don't have great measures at the post-secondary level of how these different instructional practices may actually be impacting students' particular math skills or math learning. And in addition, I think as we've seen impacts on students' math success, we have seen lower impacts on students' longer-term outcomes thus far, suggesting that perhaps these kinds of interventions should be paired with other kinds of supports that are longer-term in nature. And in fact, this would be a good complementary support to that, because many of the longer-term supports have focused less on the classroom instruction and more on ways to accelerate students and support students throughout their college careers. So thank you so much again for attending this webinar. This is my contact information. You're welcome to email me. And this is a website where you can find all of the reports from the Capper Center, including this latest Dana Center Mathematics Pathways Evaluation. All right, and I will turn it back to you, John.
Thanks very much, Elizabeth. That was a wonderful presentation. And as I mentioned earlier at the beginning of the webinar, and if you were joining us late, welcome. A copy of this presentation will be available to you. It's often sent via PDF. So there are hyperlinks in here, so you can click on some of the links and visit Elizabeth's website, where she has some of this content available to you. This is our final Astra Academy for the year, but we will be returning in 2020 in the spring semester with additional webinars. So do make sure that our distribution list. If you're not, when you receive the presentation, you can email me back and we'll be happy to add you for additional presentation. And then, as always, we have our annual users conference in the middle of October, and we have selected the dates already, which will be October 18th through the 21st. So we hope that you will be able to attend that as well. I do want to open it up for questions. I received a lot of questions in the interim, and thank you very much for that. I'll begin with a couple just ground level questions, Elizabeth. And I guess first is the report on your website that details a lot of the stuff that you've talked about today? And if so, how do people access and review the Data Center Mathematics Pathways curriculum?
Yes, the report was just released 2 weeks ago, so it's hot off the presses. You can find it on that post-secondary readiness web link that I had up on the screen. You can also find it on MDRC's website. And I believe it's even, if you went on MDRC's website, I think it's actually up on our beginning page right now, since it was just released.
Great, thank you. And so for those of you that when you receive this presentation, maybe the easiest thing will be to click on that website that says post-secondary readiness. We'll make sure that's hyperlinked so that you could just click on it and it will take you right to the page through the PDF. One clarification question that someone asked, which was, I think it was related to the total credit slide of 15.4 versus 19.3. Is that an average for students overall, or is that one semester? So I think they wanted to know a little bit about the timeline. And maybe it's maybe 4 or 5 slides back, but the one slide, I think, if the participants recall, the control group was a little bit higher than the experimental group. What was the duration of that?
So this is an average across the groups. And it is after 3 semesters. I think this might be referring to the exploratory analyses we did with students with fewer developmental needs. And yes, so those students, it would have been the average credits that they had earned after 3 semesters.
Okay, great, thank you. So that's over 3 semesters. Going back earlier in the presentation, there was a discussion that said something along the lines, I think it was about 55% of students, or there was a 55% increase in students' response as it relates to improving working with others in the group.
Mm-hmm.
Was there any focus group or qualitative context to that, where that seemed
Yes.
a significant jump? Did you learn anything about why students felt that way?
Well, I think in part, this is these principles and the kind of is sort of how, or the standards of learning, kind of, if you want to say, are basically what the DCMP curricula is written around. So the prompts given to teachers within the curricula is very much focused on breaking students into small groups and having them work together in every class period to do these multi-step word problems, or working through these solutions and finding their solution methods. So it was a standard part of the class. And I think the one thing I didn't mention around that, there were a few challenges, like if there were students that there were really small class sizes with this kind of more active learning model. But in general, students we would walk into the room and students would, in many cases, already be divided into groups pre-existing groups that they knew each other and were working, already on problems. So anyway, and that is written into like I said, into the curriculum, and then supported through the trainings by the Dana Center, both an in-person training and online trainings, and they also have a thing called group spaces where instructors can provide example lessons and kind of chat about how to implement the courses.
Sure, sounds great. Another question from the audience. There are much more data around pathways and co-requisite for statistics and quantitative literacy than for college algebra. Can you see why this has been the case, and what might be done about it?
Yes, I would agree. I think part of the reason for this focus is because the algebra and calculus pathways have been the traditional standard model for colleges. So I think part of the work has been to focus on whether or not a different type of math course can allow students to still be successful in the short term and the long term. Some of the big questions we often get from faculty, or hesitations, I might say, about implementing this model, is that students need algebra and that they really can't do without it, and that you're dumbing down, or somehow not, statistics and quantitative reasoning are not as rigorous, and not providing students with the math that they need for their future lives. I think a lot of this study is focused on figuring out whether or not that statement is true, and providing some evidence about whether or not students can in fact succeed longer term, or if they are hindered by not having algebra and calculus courses. Another reason, I think, for the focus on statistics and quantitative reasoning, I think, as I mentioned in this particular study, the development of STEM-focused pathways has been slower for some of these leader organizations. So when we started this study, the path to calculus and the curricula for that had not yet been developed. It is now available, and so you can implement these kinds of active learning contextualized models in STEM-based courses and algebra courses. And right now, MDRC is looking a bit at a STEM-based model that does incorporate some of these types of things, and trying to see if we can do a rigorous study around it. So stay tuned.
Sounds great. We have another question. Someone writes, and we work with about 50 institutions of higher education in the state of Texas alone. She writes, our institutions here are pretty diverse. Did you look at some of the demographic differences in pathways between students?
Yes, We did. Those are included in the report, and just there was actually no differences across student groups by race, ethnicity, gender, or some of the kind of the traditional groups. I provided you with information in the areas where we found statistical significance, but we also did conduct those. And the sample itself was fairly diverse. We had some colleges that were predominantly Latino, along with other colleges that were predominantly white or had larger percentages of African Americans and other students of other races and ethnicities.
Wow, okay, so just to be clear, that there were no differences, no statistically significant differences by race, whether it be Latino.
Correct. The pathways were, another way to say that more positively, the pathways were successful for all students in the same way.
Absolutely.
So there were no, it wasn't that one group benefited more than another.
Yeah, that's great news. I noticed that there were some differences in full-time and part-time. Particularly, there was a significant improvement among part-time students, where previous research has highlighted that might be a reason why students aren't retained, a very long pipeline. Can you talk some of the differences between full-time and part-time students in the data center work?
We didn't really study for instance, in focus groups or site visits, we didn't really ask students whether or not they were part-time or full-time. We knew that in the quantitative analysis that this is a outcome of interest for the very reasons that you just mentioned, that part-time students tend to be less successful than full-time students. So I think the fact that we saw impacts on part-time student success is great, and helping, showing some encouragement that we can increase the success rates of those students. But in terms of finding out what their thoughts were, if they were part-time or full-time, that would have to be a further study, another study.
Sure. Another question, I think this is from an actual math instructor. Are there problems or help guides available for people interested in improving the curriculum based on, I think they're asking about some of the problems that you showed earlier, Liz, about.
Right.
Yeah.
Yes. The Dana Center has each of these classes. When I started the presentation, I showed you those pathway courses that they have developed, and they have curricula for each of those pathways. So it's 5 different courses that they have developed curricula for that can help support that. The Dana Center also now has a new online training and development to think about how you might integrate those into your own teaching, so not necessarily using their curricula. So I would encourage you to contact them and to see what resources are available. Our report in the cost study section also talks a little bit about the kinds of services that the Dana Center offers that are similar to what the colleges received in this study, so you can also look there to get a little sense of that. But overall, call the Data Center.
Sounds good. A colleague asks a question about, earlier you mentioned that part of the research on pathways and co-requisite is to reduce exit points. Were you able to isolate what impact reducing the exit points had on your research? That is, I guess, in terms of the pathway, simply changing the structure of the pathway, what effect that had versus some of the intervention of changing the curricula and that kind of thing.
Right. I'll have my kind of standard answer for these kinds of studies. Given that this was a kind of package together, so the acceleration along with the change in instruction, we can't really say what difference was due to the difference in instruction and curriculum and what was due to the acceleration. I think other studies have certainly shown, of math pathways, have shown that this acceleration is a significant component of helping improve developmental students' outcomes. So I do think, I guess I would say, I don't think we can't disentangle in this study whether or not the teaching and learning, whether or not that really, how much did that impact students' academic outcomes, but I do think you can see that it impacted students' perspectives, and certainly the ways that they learned math. And so, I think that in and of itself is a statement of importance, so whether or not it was due to the acceleration or curricula, whether or not students feel more confident with math seems to be a really important thing for us to be learning during this time as well.
Sure, we have time for a couple more and a lot of other questions, so this is great. One clarification, and maybe you can help me out with this. You mentioned highly contextualized. What did that mean? I think maybe earlier on you might have mentioned.
Right. Yes. It's unfortunate I can't give you more examples, but I can tell you more examples. So for example, one class that I observed when I went in, students were given a problem where they had to they had to read about this, figuring out whether or not a salesman that had come around that wanted to basically do landscaping in their for them as kind of a package price, whether or not that was a good deal in comparison to buying the components of the landscaping on their own. And it gave them kind of an odd shaped yard where they had to be able to figure out the area of triangles and rectangles and figure out the difference between perimeters and area, because it would be like fencing. Some of it would be fertilizer that had to go on all the grass, some of it was sod. So there would be these kind of multi-step problems where they'd have to kind of solve, well, how much would it be for this part of the yard? How much would it be for the fencing? And then in the end, they would be adding that all up together and comparing that with this overall package price that the salesperson had given them. So that's an example. Another example, students were asked to measure things like blood alcohol content after a certain amount of drinks, and whether or not a person would be safe to drive. They were asked to compare different discounts and sales based on things like whether or not there were 12 fluid ounces in something versus 8 fluid ounces, and what the differences in price were. So they had to do a lot of manipulating of comparisons. They were also given a lot of graphs and charts where they had to interpret things like bulk prices, and so if you had one of an item, it would cost this. If you had 20, it would cost this other thing. And then they would be given a problem where they had to think about different numbers of items and what would be the best deal. Those are kind of some examples of some of the contextualization.
Sure, that's very helpful. And I guess with the time that we remain, there's a couple just technical cleanup questions, and then I'll end. I think one of the questions was, do you have any recommendations, or do others do control work like yours? I presume that's referring to math pathways, but maybe more generally, if there's others who are doing RCT type of work.
Mm-hmm. I would encourage you, yes, to look at the CAPR website. We had a number of different researchers that we partnered with that also worked on doing RCT work. And then both the MDRC, we've done a number of different RCT studies of a number of different developmental and non-developmental education reforms in two-year colleges in particular. So I would encourage you to really look at our post-secondary education website. There's also the Community College Research Center also does a number of studies, either in partnership with MDRC, but also on their own. And those tend to be more quasi-experimental studies that do some statistical controlling. But those would be other places to look.
Yes, and our colleagues, and previously we did a webinar with the CUNY ASAP program. So yes. That might be another opportunity for people who are interested to go back and look at that webinar. It's also free. Finally, in the time that we have left, I want to thank you all for attending, but I thought I would close with one question. Was there anything that was particularly an unexpected finding, or something that was particularly interesting that now that you've kind of completed this research, that you're interested in investigating further, and where that might lead?
Yeah, I guess for me, I think I guess I was surprised at the level of difference between students in the standard classes and those that were in the DCMP classes, just the stark contrast in the experiences they had in learning math in their classes. I hadn't really, I had heard that it was kind of all teacher-led and lecture, and, you know, I mean, in some ways it was kind of sad, surprising that there was such differences. And I guess for me, having, you know, conducted the study, sat in these classrooms, I can't help but want to do more research on how can you integrate some of these more contextualized active learning models for students learning math, and whether or not that would show some longer term differences on students' attitudes towards math. I think with, you know, it's kind of hard to do that with one class, but I wonder if students had a number of math classes that looked like these, or even in, you know, more discipline specific courses like this, if there might be a change in attitude about how math was used, how it applied to their everyday lives, and how it might apply to their careers.
Absolutely. Well, that sounds very interesting. And thank you so much, Elizabeth, for presenting today and sharing with us your research. And thank you all for those attending the webinar. We thank you very much. And a copy of this will be available to you shortly. Thank you all very much for attending, and have a great rest of your day.